So hello, I'm Kiril. Thank you for coming. Thank you for organization of such event. Thank you, Mojo, Eric, and sponsors for backing us up. Let's start. So Kubernetes is cluster environment for Magenta 2, and what flexibility it gives us. So I've spent a while working within Magenta itself, got certified, 3 years within Magenta itself, and 4 years in the world for now. So the talk would be, this is kind of agenda. So how it was before, why we came to Kubernetes stuff, how it fits Magenta cluster, how Magenta components and all the subsystem components are built on it, then what do you have now and where everything is going as of what I see now. And something about the deployment strategies on how we manage this stuff, all our cluster and deployments inside. So back a while ago, years ago, I had one computer with one CPU. It was great. Then fellows started building the multi-CPU computers. They needed more horsepower, more machines, more environments. Clusters started getting up and running. Then virtual systems got a bit slow. The containers are a bit faster, lighter. They became mainstream a while ago, kind of a couple years ago. So the point is, world is moving fast, and we need always faster, secure delivery to our environments. So speed things up, 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 up. So I've been working with AS400 systems, great system from IBM, mainframe. I've been compiling Docker machine stuff to deploy within the VMware configuration. Spent a while working with Amazon Web Services EC2, about 10 years since I got into Linux environments. All of this is going forward. So who knows what Docker is and how it works? Who's aware of Docker? Who used it in production? OK. So Docker allows us to make a standard environment and keep this environment across all the stages, from development, staging, and production. Completely the same environment. So if you're using Linux for development, then you're pretty sure and you're pretty right with the deployment, because you can deliver just what you built. Besides that, it also allows the higher isolation between the applications. You can limit the CPU horsepower's memory utilization for specific application, like put it in a box. So this is how Docker is basically built of a bunch of boxes, a bunch of standard components. So with the history, if we have components, then we have to ship them. If we ship them, we have to have all the infrastructure to ship them. So there is Zoo came in next to orchestration tools from the DevOps area. So the Amazon containers, Azure containers, CoreOS containers, even Swarm, Rancher was at the time, Kubernetes, and Marathon, OpenShift from Red Hat based on Kubernetes. So all these got wild. So Cloud Native Computing Foundation is actually backed up with the Linux Foundation, just took it over. Like nearly standard environment, like with Linux, like with something we get used to. And let's probably go forward with the needs of our DevOps stuff. So we need environment variables, persistent storages, runtime layers, health checks, all the monitoring, aggregation of all the logs centralized, some sort of tracing tools, logging, the tools for delivery, tools for discovery, tools for routing, tools for balancing. All these are backed up with the Kubernetes-based framework. So Kubernetes, it's not just yet another orchestration tool. I'll tell a bit later with some code. Basically, it provides components we usually need for the application construction, and it provides abstractions for tools we got used to, like service, entry points, configuration, deployments, disks. Also, we're aware of there are other tools that can be added. The Red Hat added his router specific. There are other tools for monitoring and transitioning traffic outside from the Kubernetes environment. Exgress. Besides that, there is also a way to hook up networks, so you will be kind of in the same network within Kubernetes native network and access services from outside using the same service discovery systems. So Kubernetes handles a lot of headache, self-healing stuff. The point is that in Kubernetes, you define the final state of the system. It's declarative. You're defining what system should look like, and it will rebuild itself to match. So on the other hand, Kubernetes really helps for data centers to optimize the utilization and power, because it stacks containers next to each other, closer to each other, to optimize the latencies also. So within schedulers and within subsystems within Kubernetes, it's a set of subsystems, scheduler, health checker, log collector, API to do stuff, completely fault tolerant. If some system goes out for a couple of minutes, it won't be a big deal. If everything crashes, yeah. So this is how it looks like from its dashboard. We have namespaces, these kind of projects. We have actually the abstraction layers. We have the configuration parts. There is part of security in here involved. We can pass configuration securely in terms of it will be stored for environment and can be used by developers, but actually won't be shared. The credentials for database, for example, secure keys, and this kind of stuff. So I will zoom it up. This is how the stack of all the components would look like in a Google Cloud. A lot of things, there will be more. Usually a stack is quite big. And this is why I don't trust people who say, I'm full stack developer. You develop all this or more. So let's start. Entry point. Within Google infrastructure, we're able to define a static global IP. And then we're using the ingress as an entry point to our location. And one more thing, we use configuration within Kubernetes itself to run things. We are mounting configuration to the containers themselves. So entry point. you can specify, and within Kubernetes environment, there is a tool called Kublego, L-E-G-O. So let's encrypt for the Kubernetes environment. So it allows us to bring HTTPS directly. So then we specify simply the service, the entry point. It will be discovered by DNS in the local environment. Local DNS is running for service discovery. For configuration maps, for all the configuration, we are able to push all the configuration straight from the files as they are. And then we are mounting these configurations across containers we need. We can remount configuration. We can do a lot of things. So getting to the main part. We got through the entry point, which went to varnish on the top, and through the ingress initial entry point. We got configuration. We got HTTPS. Then we have deployments and services. So service itself is just declaration of entry point. It doesn't have anything more. Actually, the development deployment is the set of containers that is getting ramped up once you define it. It will mount all the configurations if you need. It will mount all the persistent layer, and you can route through the local network, like just database or just Redis. It will be the same. So deployment. Here's the interesting part. Kubernetes defines API version, which actually defines the set of tools, set of abstractions. It makes actually Kubernetes live longer because of keeping backward compatibility. And like with SAP or Oracle, backward compatibility is really, really needed thing. And Linux store worlds at the time thought few bad words through in a guy who tried to drop backward compatibility. So this is why we have strict API. Your code will live for decades from now on. So about persistence layer. It allows us to mount remote locations, for example, via NFS if we have to make it shared. But there are a ton of other persistent layers, the Google Disk, the Amazon layers, whatever you want. And it gets mounted as a local file system. So in terms of development, engineer would not even find the difference between working within local environments, within local systems, and remote ones. If it's just mounted, like local one. This is how usually I mount media folders within Magento. Just mount it, and it will work. So what we're getting? We're getting, with Kubernetes, we're getting even flexibility with getting outside of the vendor lock or service provider. We're just getting bare metal, ramping up there. Reusing all the configuration over and over again. Code, once more, kind of competitor with Ansible, Tower, Ansible, Puppet, Chef, but not. It's different. It defines actual construction of your application environment. Like an organism, you have to have head, you have to have hands, and each part does its own thing. And with overload, you have to do a lot of stuff a bit differently. So centralized logging, and you can put more and more services inside if you want to, and scaling out of the box. So get into Magenta 2 part. So I worked for Magento for a while, so it's a mature system for a mature product with a lot of subsystems working together, needs to scale, and so on. So what we're getting out of the box with a well-built environment within Kubernetes cluster, we can get HTTP2, which is a big deal for mobile and overall. All the front-end optimizations that were done before, like sprites, merging CSS, JS, there is no point to do it anymore. It kind of kills CDNs from one point, but I talked with fellows from Nginx back in Moscow. It was really hard to make things work. And all the requests that are coming to the Nginx itself internally are coming to the single core yet, but it's pretty well. So we're getting the HTTPS offload, then we are going through the varnish. It can cache our stuff. Then we're going to Nginx stuff that will load balance after varnish. It will load balance across PHP FPM nodes. All the configuration is pulled out from the configuration map, and in here we can have different container location for cron. I usually run cron in different containers separately. There were even cases splitting cron jobs, like pulling out cron job and running it at a separate instance for integration, for extra logging, because you can throw away logging as an output, as just to std out or route it to some log within container, and it will output it directly to all the logs. And you're getting all the logs from all the subsystems at the same time. Nginx, PHP FPM, MySQL, Redis, all logs in one location. Cron, whatever else. Next to Redis, I had chance to deploy Elasticsearch with a couple analyzers, near rocket science stuff. Then we're getting deeper, we're getting to MySQL. There is an option to deploy MySQL as a cluster within same environment, reroute locations. Kubernetes allows us to go multi-region. It was released quite a few months ago, as I remember. So it allows us to go multi-region and define which region are we going to spin containers in. So we have multi-region environment on our bare metal, or mixed with the cloud. Let's say we have something on a bare metal, and then we're just adding extra volumes from the cloud, extra effort. So, and with mounting, we're mounting by NFS, Gluster, Salt. So, deployments. With deployments, you define which container are you deploying and what would be the reference to it, how it can be found within local system from service, how service actually will find its deployment. So we can reroute at the service layer to the different deployment. So actually within this project, there was FTP separately deployed. There was separately deployed SSH on a separate port. So you can isolate environments, give more environments for integrations or for other stuff you want. So what just happened? We got HTTP2 stuff with auto-scaling, with logs in the same place, we can also throw all the Magenta logs in the same place, instead of how it's often done with a cluster environments. It's like running around or setting up one more log collection tool. So easy to reproduce, because most of our environments are the same. We can spin up one more same environment and ready to deploy. And about safety, if something comes in, there are a few strategies in terms of safety, in terms of configuration, not to allow malicious code into application. So you can smash everything up and spin it up again within minutes, just in emergency case. I don't like such way. Anyway, this is the part of HTTP2, which gets loaded at the same time. We don't care. So this is the most fun part, definition of autoscaling. So we autoscale deployment PHP FPM. If it goes up more than 50% of allowed CPUs, just starting from up to 10. That's it. Under this layer, you can also use cloud formations in AWS or scale stacks. So within Google Cloud environment, there is how logs look like. And yeah, and what's going next? So within our evolving world, I remember times when I didn't use Memcached. There was no Redis. There was no Elasticsearch. Pretty much nobody used Solr. So now we can use Elasticsearch with all the fancy stuff that comes in it, even bringing AI stuff to build the models, to improve ranking. We can let SSHing in. We can reroute the traffic for live debugging. In case of we have trouble, we can spin up our debug environment like a separate deployment and reroute the traffic by cookie from production directly to even our local machine. Yes, it won't work well, but I mean in terms of performance, but it will allow us to debug on live right away. So some clients would like to print out PDFs directly from Magenta. I'm sick and tired with the building of PDFs from PHP itself. It's painful. So the best part is get best tools out there in the wild. There are a lot of good tools, and you can use the best one that suits your needs. You're not locked with even language. So you can bring all the containers that are already there and stick into your system. Yes, it's full stack. It's recommended to review what you're sticking in, just not another black box. But this is a tricky question. So integration with third party gives another isolation if you're running the same server, and integration for some reason may go too high in memory, then it will affect your traffic and probably cause delays. Or you have API calls routed separately to separate environment, isolated. So recommendations, AI agents, it's like prediction IO projects. There are a couple more projects that provide recommendation systems, all the fancy mouth, and just yet another tool, best one that you can get. So deployment. So best way to make deployments, it's like a green-blue. You're switching the version like a symlink. If you're local, if you're on a SAM server, it's just switching symlink. You're ramping up one more deployment with everything prepared and just switching. The other point comes in when you have database upgrades. I prefer to move database upgrades either straight or ahead of time, so system is ready for deployment. So, and updates are backward compatible, in terms of we're going back, and for some reason, rolling back. So this is how OpenShift looks from the inside, the Red Hat OpenShift. They have the deployments built in, so you are hooking up to GitHub or Bitbucket, and the strategy of deployment is bake source into image. So you're baking it, it has stored in its repository, local Docker repository, it's Docker registry for such cluster, it's pretty fine. And questions? Something? Was I too fast?
Hold on. Wait. Sorry.
Hi. Have you tried to use Kubernetes with Terraform, or do you manually deploy all the time, or how do you automate actually deployment to Kubernetes?
So about deployment of Kubernetes, the fastest way of deploying itself, it would be probably starting from the OpenShift version of it. You can get the Google Cloud deployment out of within a couple of clicks, they allow it. Back in Moscow, fellows deployed on bare metal. There is eBay competitor in Moscow that has its own bare metal. So it actually depends on the business strategy and the scale of the company. So large companies like Google switch into Kubernetes because it allows them to grow up the deployments of critical applications. Even if you're pushing new code, you have, for some reason, performance degradation. It will scale up. Just this part. Like sports guys, runners have big legs. Heavy lifters, they're different. So within your application, you may have kind of this of changes. So part that actually needs resources will grow bigger. And as I told before, it will allow to shrink down and optimize locations in data centers. So it's natural process of deploying Kubernetes, like deploying Magenta, because we're in great industry, which just optimizes the product flow across the globe.